Alright, before we begin, I would like to give you a heads up. That is, this tutorial is not for beginners. And in this tutorial, I'm going to assume that you already knew your way around Blender and the fundamental of the shader nodes. So yeah, I'm not going to talk about the fundamentals in this tutorial. So if you are a beginner, then please check out these videos and come back here later after you've learned the fundamentals. Okay, so let's begin. For this tutorial, I'm going to show you how to create the hexagonal diamond pattern. The first thing we need to create is the hexagonal grid. And to do that, let's first get rid of the cube and create a plane. Because the hexagonal grid is actually a 2D texture, so we're gonna need a flat plane. So next, create a material and call it hexagonal diamond. Alright. Now the first thing to do is to pull in the UV map, or you can also use the texture coordinate node and use the generated or the object texture coordinate. But these two are 3D texture coordinates, so the Z dimension will be ignored because what we're creating is a 2D texture. So yeah, the Z dimension of these 3D texture coordinates will be ignored. So let's create a vector math node and scale the vector up a little. We can always come back to adjust this later. So let's just set it to something like that. And next we're gonna separate the XYZ channel and ignore the Z. Let me just move things back a little and let's render the scene so that we know what's going on. There we go. And let me get rid of those as well. Alright, now create a math node and convert the degrees to radians, and we're going to be using 30 degrees. There we go. And next, use a cosine math to calculate the cosine value of the 30-degree angle. And next we will divide the y dimension with this value. This value here, let me just create a frame and put these in here. And let's rename this, label it height. This will be the height of the hexagons. Alright, the next thing to do is to just round this like so and multiply this with the height again like that. And this multiply node will give us the y dimension of the center points. So this is gonna be the hexagons, right? And this is gonna be the center of the hexagons, right? And this node will be the height, the y dimension of the hexagons. So let me just label this the center y. Alright, and also let me just give it a color. Alright, now create another math node and use the modulo math. There we go. And modulo this round value by 2 and then divide by 2, or you can just multiply this by 0.5. It will be exactly the same. Now we will subtract this value from the x dimension, so you subtract, there we go, and we will round this value like so, and finally we will add this rounded value with this value, and this add node will give us the x dimension of the centers. Like that. So let me just label this node the center x. There we go. And also color it something different. Let me just move this back a little. And the next thing to do is combine the x, y, z, x and y, and we will leave the z dimension as nothing, 0. And let's see the result. If you've done everything correctly, then you should have this result. And let me go back here to the scale, and you can change the scale to change the size of these cells. All right, and for the sake of it, let's try using the generated texture coordinate. As you can see, the generated texture coordinate also has the x and y dimension, so it's gonna work exactly the same. And let's see the object texture coordinate. It's gonna be at the center of the plane. So let's get back to the UV. Now this node is actually just one center of one hexagon, right? But we need two hexagons. We need to calculate two centers of two hexagons. For example, if we are rendering this point, right? The light ray hit this point. It's gonna need to locate the two closest pentagons, like this one and this one. And it's gonna calculate the distance to these two hexagons and select the closer hexagon. So we need to calculate another hexagon, all right? So let's go back here and duplicate a random math node and change this to greater than, and plug the x value into this greater than. Duplicate this node and plug in the y dimension, and let's move these two nodes here, forward a little. All right, and we're gonna compare this y center with the original y, and similarly we will compare the center x with the original x value. And let's copy this math node and connect this over like that. Use subtract. There we go, subtract 0.5. For the y dimension, we can't use this subtract, but let's use the map range node, and we're gonna map the 0 to 1 into -1 to 1 range, like so. Let's move this back a little, and we will multiply this map range node with this height value. So let me zoom out a little and connect the wire like so. And we're gonna combine x, y, z, x and y here. This node is the offset from this center hexagon to the next hexagon. So we're gonna need to add these two together. No, not math, let's use the vector math. And we're gonna add these together to get the next hexagon. All right. So this is the center of the next hexagon, and this is the center of the first hexagon. And we're gonna compare the distance between the rendering point to these two hexagons and select the closer one. So let me go back here and create a combine XYZ, and we're gonna combine the X and Y and leave the Z as 0. All right, and copy the vector math node and use the distance calculation and connect this one over like so. And another distance node, but this time calculate the distance with the other hexagon. If you have something like this, then you must be right. But if you have something different than this, then you have to go back and find where you messed up. So let's assume that you managed to achieve something like this, and let's move on. Alright, next let's create a math node and use minimum and connect these over, and let's see. As you can see, we successfully created a hexagonal grid, but this is not done yet. We need to create some more information about this grid. For example, the centers of these hexagons. And to get the centers of the hexagons, we will create another math node, and this time use greater than. Alright, like that. And create a mix vector node. If you're using an older version of Blender, then you can use a mix color node. And it's gonna basically the same, just connect these two like that, and A will be equivalent to this A color, and B vector will also be equivalent to this B color. So here I'm using Blender 3.4, so I will be using this mix node instead. And let me go back here and connect the centers. This is the center of the second hexagon, and this is the center of the first hexagon. And let's see. As you can see, we have the correct coordinate of the centers of the hexagons. Now you can actually use a noise texture to generate some random value for the centers for each cell, like so. Now I don't recommend using the white noise texture because of this situation. As you can see, the precision in Blender is not great. Even though you feel like in this cell it's all the same color, but it's actually not. So when you put this into a white noise, it might end up with two different values within the same cell. So yeah, it's not gonna work. But if you use a noise, it's gonna be fine, and you can actually just put in a color ramp to increase the contrast of the random values. So let me just get rid of the noise. Alright, let me go back all the way here, and I'm going to group everything like so, and hit tab to go back out and rename this group to hexagonal grid. Alright, let's go back in and rename the output a bit. This is gonna be the centers. Alright, and let's connect this minimum node to the output as well. This is going to be the hex grid. Alright, let's go back out and have a look. Alright, let's go back in and move this hex grid value to the top, like so. Now we need two more outputs for this texture. One is the UV of the cells, and the last will be the hexagonal polygon output. So let's create the UV for the cells first. Create a vector math and use the subtract operation, and we will subtract this with the original texture coordinate after the scaling. Alright, so connect this over here like that and reorganize the wires. Alright, let's have a look at the UV. As you can see, we have some very nice UVs for our grids, and you can actually swap the slots to basically flip the UVs. So I'm gonna connect this to the output, and this will be the UV. There we go, and get rid of this. And finally, we're gonna generate the sharp kind of gradient output. Create another vector math node and use the absolute math. Where is absolute? Here we go. And we will absolute this and create a mapping node. There we go. Rotate this by 60 degree around the z dimension, and another another mapping node, and this time we will rotate this by 120 degrees. And we will also absolute these two vectors. There we go. And next we're gonna maximum these values, these vectors, like that. And we're gonna separate x, y, z, and we will just use the x dimension like this. But this is not ready to be the output just yet. We need some more calculation. First we will multiply this by 2, and next we will flip the value like that. Alright, this will be our sharp hexagonal output. So this is going to be the hex gradient, and let's get rid of the viewer. Okay, this hexagonal grid is actually extremely useful in many different cases. For this tutorial series, I'm going to show you how to turn this hexagonal grid into diamonds. But this video has been going for long enough, so I'm going to end here, and in the next video I'm going to show you how to create the diamond shader from this grid. Alright, I'll see you next time.